Factoring is a very important skill. So far in this class, we have focused on factoring trinomial equations, which look like y equals x squared plus bx plus c. In the future, we'll start working with functions that have an a here as the coefficient of x squared, but so far we're just working with terms where there's a coefficient of 1. So if we want to factor y equals x squared plus bx plus c, we know that it'll look like two binomials multiplied together, which will be x plus p times x plus q. Okay, so how are we actually going to find it? Well, we know that p times q is equal to c, and that p plus q is equal to b. This is because this number times this number is the only number that will not have an x with it. So this is the term in the equation that does not have an x. And if we do x times q plus x times p, then the term that has the x with it will have to have the p and q add up to b in order for it to work out properly. If I wanted to factor x squared plus 7x plus 12, I would know that it would be two binomials multiplied together. Now the first term in each of these must multiply to x, so the term that goes here and here must multiply to x squared, so it would have to be x. From here we know that it's plus p and plus q, so we just have to figure out p and q. Using our method from before, we know p times q will be 12, which is the last number, and p plus q will be 7. Now we need to think of two numbers which multiply to 12 and add to 7. Well, 3 times 4 is equal to 12, and 3 plus 4 is equal to 7. So that works perfectly. So that tells me p equals 3 and q equals 4. These could be the other way around, doesn't actually matter. Now I just have to plug them in to get x plus 3 times x plus 4. Now if I wanted to say, when does this equal 0? Well, that would be when x plus 3 times x plus 4 equals 0. That means that x plus 3 would equal 0, or x plus 4 equals 0. This one would have the solution x equals -3, and this would have the solution x equals -4. So we would have two solutions to this quadratic, which makes sense because parabolas, which are what quadratic equations are, can pass through the x-intercept up to 2 times, so you can have two solutions. Function notation is a nice way to write equations which does not rely on having y equals something. So function notation, we're going to write f of x is equal to something. For example, I could write 3x squared. This says the function f with the variable x is defined by the rule 3x squared. So this is not f times x, it is a function called f which has a variable x with a rule called 3x squared. F is the most common letter you'll see, but you might see g of x or h of x, which would be the function g with the variable x, or the function h with the variable x. Now we want to describe the transformations done to f of x. In this case, we have g of x, which equals 1/2 times the function f of x. This is going to be a vertical shrink of 1/2, but a good way to see that would be to replace f of x and substitute in x squared. So this will be 1/2 times x squared. So this looks like a vertical shrink of 1/2. And it's always very important for you to tell me what the shrink or stretch is of. It's not enough to just tell me that there is one, you have to tell me what the amount is. So the amount is 1/2. This one, if I substitute in, if I plug in x plus 3 into this, it'll be f of x plus 3, which will be x plus 3 squared, because I substitute in this value x plus 3 into where x is. This has a horizontal translation of -3. This function here, if I plug in x squared, I'm going to get x squared plus 4, which has a vertical translation of 4. The standard form of a parabola is f of x equals a times x squared plus bx plus c. This parabola is very useful for comparing quadratic equations and parabolas to other polynomials, and it has a couple of properties that contribute to graphs. First of all, it has a vertical intercept, which is the y-intercept. And the vertical intercept is at the point 0, c. So the c value at the end of the parabola actually tells you exactly where the vertical intercept is. It has a vertical stretch or shrink of a. So this a value right here actually tells you what the vertical stretch and shrink of the function is. You'll notice in the other forms of intercept and vertex, they also had an a, and that a also determined the vertical stretch or shrink. So there's a reason that we used a in all of those equations, is because they all have a vertical stretch or shrink of a. Finally, we know that the vertex, let's do the line of symmetry. The line of symmetry is the line x equals negative b divided by 2a. So if I take the negative of this b value and I divide it by twice the a value, I will find the line of symmetry is negative b over 2a. And this also tells me the vertex is the point x when x equals negative b over 2a, and then the value of the function when x equals negative b over 2a, which is f of negative b over 2a. To find the equation of a parabola in standard form, our first step is to identify whether the parabola would be easier to write in vertex form or intercept form to serve as an intermediary step. If you can find both of them, then either one is fine. So this equation of this parabola would probably be easier to find in vertex form because I can tell what the vertex is. It's negative 1, negative 3. However, the roots are pretty hard to tell. I don't know exactly what values those are. So we're going to use vertex form. The vertex form of a parabola is y equals a times x minus h squared plus k, where hk is the vertex. Because we know negative 1, negative 3 is the vertex, this tells me that h is negative 1 and k is negative 3. So I can plug that into my equation to get y equals a times x minus negative 1 squared minus 3, which is y equals a times x plus 1 squared minus 3. Now I need to figure out a. A is the vertical stretch or shrink. Because the vertex goes through a point which is very clearly defined, I can look at how I change when I go over 1 from the vertex. So when I go over 1 from the vertex, I have gone up 2. This means that I get a equals 2 because this is the vertical stretch. Normally parabolas, if they don't have a vertical stretch or shrink, they go only up 1. So because I went twice as high, that means a equals 2. So I get y equals 2 times x plus 1 squared minus 3. That's great. I found the equation in vertex form, but the equation asks for it in standard form. So now I have to distribute. So this is going to be y equals 2 times x plus 1 times x plus 1, because x plus 1 squared is the same, that thing multiplied by itself twice, minus 3. So y equals 2 times, I'm going to distribute, x times x is x squared, x times 1 is x, and then plus x times 1 is x, so that's plus 2x. 1 times 1 is 1, and then minus 3, which will, I'm going to distribute this again to get y equals 2x squared plus 4x plus 2 minus 3 to give me the final equation, y equals 2x squared plus 4x minus 1 once I've distributed like terms. Once again, to find the equation of a parabola in standard form, we first need to identify whether the parabola would be easier to find in vertex form or intercept form as an intermediary step. This equation, this parabola does not have a very clear vertex, but its roots are very clearly defined. One root is at the point -1, 0, and the other root is at the point -4, 0. This means I'm going to choose to use intercept form. Intercept form is y equals a times x minus p times x minus q, where p0 and q0 are roots. If our roots are -4, 0, and -1, 0, then p equals -1 and q equals -4. Could be the other way around, doesn't matter. This will be, when I plug those in, y equals x plus 1, a times x plus 1 times x plus 4. Now I need to figure out what a is. To find a, I'm going to use algebra. I could try and see how the change happens when I move over 1, but it's a little bit hard because my vertex isn't clearly defined. So I'm going to use the vertical intercept, which is 0, 2. I'm going to plug this into my equation, so y equals 2 and x equals 0, so 2 equals a times 0 plus 1 times 0 plus 4. This is going to become 2 equals a times 4. Then I'm going to multiply both sides by the reciprocal of 4, which is 1/4. Okay, now a fourth of 4 is 1, so that's just going to be an a. A fourth of 2 is 1/2 because 4 1/2s go into 2. Then I'm going to plug that into my equation and I'm going to get y equals 1/2 times x plus 1 times x plus 4. Then I'm going to distribute to give me y equals 1/2 times x squared, and then x times 4 is 4. At 4x, 1 times x is x, so if I add those I'll get 5x, and then 1 times 4 is 4. And then I'm going to distribute the 1/2 to get 1/2 x squared. 1/2 times 5x is 5/2 x, and then 1/2 times 4 is 2. And that is my equation in standard form. Thank you all for watching, and I hope you all have a good 4-day weekend.